Hello everyone, welcome to this session. Our chapter is composed of metals. We are talking about the metal hydroxides. As for in our previous video, we saw these metal hydroxides. So in this video, let's see specifically the classifications of the metal hydroxides. So here we'll see how the metal hydroxides they can be classified. Just like the metal oxides, as we talked before, the metal hydroxides also they can be classified based on the solubility in water as either the soluble or insoluble hydroxides. So that's the first way of classification based on solubility, whereby the hydroxides they can be classified as either soluble hydroxides or insoluble hydroxides. They can also be classified as basic or amphoteric hydroxides based on their reaction with the acids and the bases. So this is the other way. Also, you can classify the metal hydroxides, whereby you can classify them based on the reaction with acids and bases, specify the basic hydroxides and the amphoteric hydroxides. Now, the classification of the hydroxides as either soluble or insoluble is known as we've seen on the previous page. Based on the reaction with acids and the bases, the metal hydroxides are classified in the basic and the amphoteric hydroxides. So this yes, the brief of what I've said in the previous slide. Now, the basic hydroxide is a metal hydroxide that it contains the hydroxide ions and it will react with an acid from salt and water only. And the amphoteric hydroxides is the hydroxide that shows both acidic and the basic properties, that is, will react with both acid and the base. Example of the amphoteric hydroxides, here we're talking about the this aluminum hydroxide, zinc hydroxide, and the lead hydroxide. Now the amphoteric hydroxides they behave as bases and as acids under different conditions. These hydroxides they are only weakly basic, but like other bases, they still combine with acids to form salt and water. As you can see with these examples, zinc hydroxide plus this sulfuric acid leads to zinc sulfate plus water. Also, as the lead hydroxide plus this nitric acid leads to lead nitrate plus water. The same goes to the aluminum hydroxide plus hydrochloric acid leads to aluminum chloride plus water. So these are just examples on how these hydroxides they can react. Now, however, in the presence of the strong alkalis, these hydroxides they behave like acids and they combine with these strong alkalis to yield salt and water. As you can see the examples here, the zinc hydroxide by these alkalis, specifically this sodium hydroxide leads to this sodium zincate plus water. The same goes to this lead and the aluminum hydroxide with the reaction to this sodium hydroxide leads to example for the lead leads to sodium plumpate plus water, and for the aluminum leads to sodium aluminate plus water. So that's all I have for this session. I hope that's all clear. I've seen the various classifications of the metal hydroxides. So I hope that's all clear. And thank you. And in our next video, we'll move on to the other subtopic, that is, we'll see the various properties of these metal hydroxides. Thank you.